Okay. Hello, everybody. So this week we're going to have our lecture recordings posted on Blackboard. So we're not going to have any Zoom meetings this week. I'm sorry about that. It's because of my work. I have to work late for this week, and I probably won't make back on time for the starting of the class. So today, let's talk more about SolidWorks modeling part. And next week, we're going to go in deeper about the drawing part. So first of all, today's topic, we're going to cover about design tables and maybe a little bit hole wizard and circular pattern, something like that. Just some features that you guys never tried before. So I have SolidWorks opened up already. And you can see this one is a piece of flange. And the design parameter are based off a ASME B16.5 standard of a NC 150 pound rating flange. And we can find the information online. You can see SME B16.5 and class 150 means it's a 150 pound rating. And these are a pretty much roughly estimate. You can find the more precise ones from SME or other website. But this one is good enough for our level. So let's use this as our design parameter for different flanges. And what does it mean by design table is actually, if you're gonna design a standard part. So for example, this flange is a standard part because the standard already been standardized, and every value from for different sizes are fixed. So in order to save us time and make this part easier to use, we just design one part and input everything, input every parameter into a table, so the SolidWorks can auto-generate the other parts for other sizes, so that this part is going to be a one-part file, but contains so many instances that corresponding to different sizes. So I'll say it's a pretty powerful tool, and we're gonna go into it right now. So before we start design table, I suggest you guys to open up Excel, because this design table gonna pretty much open Excel for you when you're using the SolidWorks. So if you have your Excel open up already, so you can save some loading times. So I have opened up right here is blank, and just open SolidWorks and Excel at the same time. Okay, so actually, the one you're seeing right now, this flange shown right here, is 8 inches flange. The reason it's called 8 inches is because I know the outside diameter is 13.5, but actually is nominal pipe size is 8 inches. So if you're familiar with the pipe schedules, you will understand why it's called 8 inches. And the other instance is 10 inches. You can see the whole numbers are completely different. The OD and the ID and the bow circle, everything is different. So this is another instance inside of this part. Okay. So from the model tree, let's see, it has one extrude, and the sketch is under the extrude, and the hole, and the pattern of the hole. So it's a very simple flange. All right, let's make an even easier one to show the magic of the design table. So open up let's create a new part. So this is completely blank. So start off the front plane. Let's start making a tube. So make 2 concentric circles. And the first one, 2.5 sounds good. And let's have this one 3.5. So fully defined, and extrude this one. Let's have a length of 10. So very simple and straightforward. One feature part, just a tube. And let's apply the design table for this tube. For example, I want a larger tube or longer tube, and maybe at the same time the both. So search right here for design table. You can see design study and design table and blah, blah, blah. The second one is design table. Click on that. The property manager pops up, and we want a blank one because auto create, you don't know what's going to create, and I prefer a blank one. Or if you already have an existing one, for example, you have designed a bunch of tubes with design table, or as known as family tables, you can just import the table from there, so you don't have to pick every dimension manually. But since we're starting off with a brand new one, so let's do the blank. So wait for it, and now this window pops up. Pretty much, it asks you about the configurations. You say okay, and now it seems like it froze, but you just click anywhere, and you'll see no valid design table instance were found. This is normal. It's okay. Click OK, and you want to access your design table, come here. Configuration Manager, click on it, and right here there's a table tab, and you open it up, and there's a design table, and this is the design table we just created. So right click, add a table. So you have your design table right here, and you can change how big it is. You see this is exactly Excel. That's why I told you guys to open up Excel ahead of the operation, so you can save some time. And if you want to go back, and if you just click anything, if you click anything right here, your table will be gone. That means your table will be automatically saved and closed. So don't panic, you're not losing anything. You just go back to configurations and design table and add a table, and it will show back on again. So just to let you guys know. So what's the fill in right here? The different columns will be different, I'll say, dimensions. We want to have, for example, the first column, for example, the length, and second column, for example, the outside diameter, third column, for example, the inside diameter, and have its own magnitude according to every instance. So how to make that happen? So click the first column, just the top cell in the first column, and come here, the annotations, right click. You see the design table's gone because we're trying to make some move in the feature tree. Here, it's just show feature dimensions. And click it, you'll see pretty much 3 dimensions pop up. And these 3 dimensions are what we just entered, right? If you click one of it, the dimensions property will show up right here. And look, pay attention right here, it says primary value. So this is the magnitude, and this is the name of your dimension. And if you want to change it, because sometimes when you're dealing with a complicated model and you forgot which dimension represents what dimension, right? So you need to change your name. Like for example, this is the inside diameter of the tube. We can change the name to ID, inside diameter, right? And this one, it says it's D2. We can change it to OD, outside diameter. And actually, there's one more feature right here. The little eyeball right here, there's a drop down list, and if you so if you check this one, view dimension names, you will have your dimension names right next to its value. So let's click this one. So it's checked. So you can see this one called ID, this one called OD, and this one is unnamed yet. It's still called D1 for extrusion. So let's change this one to lane. So it's completely up to you. You want to change, you want to name your dimension, go ahead. If you don't want to, just memorize which dimension represents what. All right. So once we have all the dimension named, let's go back to the design table, edit table. All right. So pretty much the default cell is automatically clicked is the first cell of the second column, right? So you just select any dimension, you can see. So click on it. For example, the first one I want length. Click on it. Sorry, double click. Yeah. So you can see right here, the name already become length and the magnitude is 10. And now second column, double click the ID and ID 2.5, it matches. And the third one, click on the OD 3.5. So right here, the first column is the names of your instance. First one says first instance, and let's change it. I want to call it, for example, tube 1. All right, and if we drag it, due to the characteristic of Excel, is tube 1, tube 2, and tube 3. All right, that's pretty good name so far. And the length, I want to make this, I'll say longer and longer, 15 and 20. And the ID 2.5. Let's do 3.0 and 3.5. And OD, for example, let's do 4.5 and 5.5. So this tube is going to be bigger. The tube 2 is going to be significantly bigger than tube 1, and the same to tube 3 will be significantly bigger than tube 2, right? So once you enter all the parameter, you can click anywhere, so you're going to automatically save and close. And it tells you those instances are generated, right? Okay, so now I see the dimensions become pink. That means those are controlled by the design table. So you double click on any instance. Let's see, this is the first instance, 10, 2.5, and 3.5. And the second one, it grows bigger, right? And the third one, double click, it goes a lot bigger and also longer. But if you go back to your model tree, you can see it's still treated as individual parts. So pretty much you have one part that's gonna change under 3 different conditions. And this is still gonna be just one part. If you save it, it's still gonna be one part. So this is pretty much the very introduction about the design table and how to use design table. So let's try something a little bit more complicated, such as the flange, because the flange definitely has more values to enter, right? We're gonna enter this, we're gonna pick a few instances and enter this table to reflect the changes. So we're gonna have different sizes of flange, different numbers of holes, and such and such. Okay, let's make a new part. So pick a plane and same thing. Let's make 2 concentric circle. So that represents our flange. So you're gonna, when designing the first one, we need to pick one. For example, let's pick size 6. Size 6, 8, 10, those are very common size in industry. So size 6 will have the thickness of half, and OD of 11, ID of 6.72, total of 8 holes, and the hole diameter is 7/8, and bolt circle is 9.5, and the weight, we don't really care. So first, let's do 11 and 6.72. 6.72. All right. So we have our 2 circles, and let's extrude this to its thickness, 0.5. All right. So we have our ring right here. All right. Okay, and now let's put holes around this flange. So instead of doing simple hole, because remember last time we introduced how to use simple hole feature, right? Let's do hole wizard. Hole wizard is the same, pretty much same feature, but contains more information. So I'm gonna see right here, different type of holes, tape, like countersink or counterboard, and blah blah blah, like those. Pretty much, the counterboard and tapped board, straight tab, and the hole are very common. I have used those in person, and this time let's just do hole because from this picture you can see just through holes, right? So this time, I would say pretty much no different than using the simple hole feature. So standard, bunch of standard, let's use ANSI inch. Pretty much that's a very common one in the US. The hole will be 7/8 because it's 0.88. So if you're not familiar with the fraction conversion, just download a chart, and for long enough, you'll remember as that. And gonna be through holes. It has a bunch of different options, but this time it's gonna be through hole, and everything else is doesn't matter this time. All right. So right here it says hole position. So pretty much just place your hole in anywhere, but pay attention. For flanges, normally the holes are aligned with the origin. So when you see the vertical line, let's make it vertical so you can see better. So when you see the vertical line, that means it's going to be exactly aligned on the y-axis, and this is good. We want this to happen because the first hole, right, it should be somehow reference to something. So let's place it right here and check OK. So you can see the hole is placed right here, but still the location is not fixed. So we're starting to get into the sketch and make a circle because there is one parameter telling us what is a bolt circle is, a BC. BC is 9.5. So we need to make this parameter happen and make this to control the location of the hole. So you do a circle, and now you see the circle can connect with this origin of this circle with the hole, right? So that's what we want to do it. And we'll make this for construction because this is not a real circle we're making. We're just making a reference circle to locate the hole. And we set this to 9.5, which is exactly here shows 9.5. And you can see the origin of the hole moved up and still connect with the bore circle we just created. Okay. And now you see this hole is light exactly where we want it to be. And if you want to make sure, you can measure this. And you see the distance is 4.75. The radius, if you times 2, that's 9.5 exactly as bore circle. And the measure tool, also I want to introduce some other functions. For example, if you want to know the exact distance from this edge to that edge, let's see, if you click these two, it won't tell you, it just tell you the center distance, but you can adjust from here. So right here is a custom distance. So the first arc you choose, you can say you want maximum, and the second arc you choose you want minimal. And that will tell you the custom distance is 0.31 inch. And a little bit common sense, if you clearance from your hole to the edge of the flange is more than a quarter, most likely your flange will be good. So just some experience. All right, so we have one hole. How many holes total we need? We need total number of 8 holes. All right, once we have the first hole, we can click that and go into feature, and there's patterns. Last time we used linear patterns because go linearly, we create 1, 2, 3, 4, left and right, right? So this time we're gonna follow a circle. Let's do circular pattern. So first of all, direction. Direction is where you want this hole to rotate. You want this hole to be rotate clockwise or counterclockwise, but it's gonna be rotating some axis, right? So which direction is gonna be consistent with this pattern direction? It should be this surface, because this surface is rotating about the center axis. So you click that, you see the preview, we already have number of 8 holes, but they're crowded at left side. Why is that? Because the angle between each hole is 15 degrees, but 360 divided by 8, that's 45 degrees. And we enter 45 there, we have all the holes distributed equally. Right? So you click OK. So pretty much this concludes our flange. Very simple, straightforward, just one extrude and making a hole and pattern the hole. All right. Once we have this, and we can start making our design table. Search that design table here. Open it up and choose a blank table. And same deal, click OK. And click somewhere, and it will tell you the table is not found. The table is right here under configuration and under table and add table. Okay, table showed up, but dimensions not showed up. You need to go back, and from this annotation tabs, right click, show feature dimensions. So there you can see all the dimensions showed up, OD, ID. Wait, where is the ID? Oh, right here. Yeah, drag it out. Yep, OD, ID, board circle, and even the angle apart and number of holes, blah, blah, blah. Okay, be careful. Here is a 0.5, but this one is hole depth, is not the thickness. This one right here is a thickness of 0.5. So just pay attention, read the name of the dimension, and don't pick the wrong one. Because if you pick the wrong one, it will generate based off the wrong input. So come back to your design table again, add a table. So the first one, let's see how this aligns. First one, thickness. Oh, I misclicked the surrounding. So this design table is gone. All right, first one, thickness. Second one, OD. Third one, ID. All right, let's follow this. First one, thickness. I didn't change any name because I can surely remember what the dimensions represent for. Second one, OD. The third one, ID. And let's change the column width so everything can show all together. Fourth, number of holes and hole diameter. Number of holes is 8. Hole diameter here. This 0.88 shows through hole diameter. And bow circle. All right, we have everything right here. And somebody may ask why this 45 degree is not in there. So I left it off in purpose. Let's see what's gonna happen once we have this design table completed. All right, so let's do 6, 8, and 10, total of 3 instances. And 6, 8 pretty much is, they're all a 0.5, and this one is 0.625. So enter 0.5, 0.625. So OD is 13.5 and 16. Eight 8.72, 10.88. 8 and 12. 0.88 and 1. So actually it's 0.75 and 1 because the sig figs, they round it up to 0.88. And 9.5 becomes 11.75 and 14.25. All right, we complete the table. All right, click anywhere. It closed, all right? And tell us total of 3 instances generated. All right, let's double click on the 6. Looks okay, exactly as we designed, because the input is the first instance is what we just designed, what we just sketched. Right? So 8 inches, slightly bigger compared to 6 inches. See, right? Expand, and 10 inches. So 10 inches, what's going on? Look at the number of holes. It still shows total of 8 holes, right? And we want how many? Right here, we want 12, but it still shows 8. What is going on? Let's open up the design table. So you see, we clearly input 12 holes right there, but only 8 shows up. Why? This is because excuse me. It's because that 45 degree wasn't taken into account. So 4 of the 12 holes overlapped with the initial 8 holes. So only 8 holes displayed. But the 12 holes still there, but 4 of them are overlapped with the other 4 holes. So therefore, we need to add a new column and put this 45 degrees into the calculation. So 8 holes corresponding with 45 degrees, 12 holes corresponding with 360 divided by 12, that's 30 degrees. All right, so once we make this change, we close it. And what does it show now? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 12 holes. So that means if your model is not what you want, you better double check. Yes. So once you change anything, you need to rebuild the whole thing. Even though it might not take effect on other instance, for example, these two are still the same, but it's starting to rebuild because all three are linked together right now. They're all under one part, just controlled by different parameter. So no matter how many instances you generated, after complete, please go into each individual one. Even though there might be no warning, but still go into each individual one to inspect the part. And anything looks suspicious, you need to go back to your design table and make the change until you get what you wanted at the end. Okay, so I believe this will conclude today. Oh, and right here you see this part, the name is changed because this instant is showing the 10 inches. So the name is changed correspondingly, but this is still under the part we sketched. So it's still one part, but 3 instance reference. Okay, I think this is the basic about design table and a little bit about hole wizard and the circular pattern. Any question, please either email me or save it till next lecture. And next lecture, we should be in Zoom. And I'm there to do more examples or answer questions. But next week, the primary goal is to show you guys the advanced drawing so you guys can have more enough time to prepare your first project. So this week will be a pretty light exercise. Just play around with design table. You know, is very powerful because we use this a lot on standardization project. Okay, so let me know if you have any question. And this is today's lecture. I'm gonna upload this to YouTube right away. All right, guys, have a wonderful week. See you.